Hi, my name is Janani Ravi and welcome to this course on performing dimension analysis with R. A little about myself. I have a master's in electrical engineering from Stanford and have worked at companies such as Microsoft, Google and Flipkart. At Google, I was one of the first engineers working on real-time collaborative editing in Google Docs, and I hold 4 patents for its underlying technologies. I currently work on my own startup, Lunicorn, a studio for high-quality video content. In this course, you will gain the ability to design and implement an exhaustive array of dimensionality reduction techniques. First, you'll learn the importance of dimensionality reduction and understand the pitfalls of working with data of excessively high dimensionality data. Next, you will discover how to implement simple feature selection techniques to decide which subset of the existing features we might choose to use. You will then learn important techniques for reducing dimensionality in linear data. Such techniques, notably principal components analysis and linear discriminant analysis, seek to reorient the original data using new optimized axes. You will then move on to dealing with manifold data, which is non-linear and often takes the form of Swiss rolls and S-curves. Such data presents an illusion of complexity, but is actually quite easy to work with. It's easily simplified by unrolling the manifold. Finally, you will explore how to implement a wide variety of manifold learning techniques, including multidimensional scaling, isomap, and TSNE. You will round out the course by comparing the results of these manifold unrolling techniques with artificially generated data. When you're finished with this course, you will have the skills and knowledge of dimensionality reduction needed to design and implement ways to mitigate the curse of dimensionality in R.